I'm Steve Highsmith. NASA is ending the 30-year shuttle chapter of its history with the final shuttle flight. Shuttle Atlantis' commanders, Chris Ferguson and Archbishop Ryan, and Drexel graduate, and he has family in Bucks and Montgomery counties. Drexel has another reason to be proud. Yep, that's some students cheering. NASA launched 2 weeks ago this unmanned rocket from Wallops Island, Virginia. Aboard were several experiments from just a handful of universities who won a research competition nationwide. Drexel and Temple University projects were aboard. Temple's experiment dealt with the problem of launch vibration. Drexel's concerned de-spinning, or preventing a payload or a satellite from spinning in a rocket that has to spin to remain stable. They may have discovered an inexpensive way to do just that. And with me now is Dr. Jen Kang, professor of Space Systems Laboratory at Drexel University, and two students. Joe Mozloom is here, and also Swapnil Mengawade is here. Thank you very much for being here, and congratulations on your project, which is partially in front of me right here without its housing around it. So what was the problem you were trying to fix, Joe?
Well, as most of these sounding rockets, or all of these sounding rockets ascend, they rotate in order to be stable. So
they have fins on them. They're accelerating up, but to keep them from going crazy, they have to have a spin.
Correct. Similar to how a quarterback might rotate a football to keep its trajectory.
And what's the problem? Why is that a problem?
Well, not all experiments might want that spinning. So,
like a biological experiment or something?
Correct, or anything that is sensitive. There's a lot of G-forces associated with the spinning. And anything that's worried about a specific point in space. So solar measurements, radiation measurements from a star.
Well, NASA must have some way of doing this already.
Sure. Normally they de-spin the entire rocket. So they release either a boom or gyroscopically inside the rocket, they de-spin the entire thing.
But that's expensive because of the weight involved, or because the gyroscope's expensive?
Right.
So you guys came up with what? What's your solution, Swapnil?
What we did was we fixed a few accelerometers which measure the spin in all the three axes. So when the rocket is launched and it is spinning, it measures the spin rate of the rocket. Then takes the data, feeds it into the microcontroller, which later feeds it into the motor, and the motor spins the rocket with the same spin rate but in the opposite direction. So this creates a platform which is stable with respect to the space.
Do you get high definition on this? No. On demand, internet. No. This little thing, right here, this thing, this inexpensive, relatively inexpensive compared to that. It's what, about $1,200?
Nothing
compared to what's in there. You figured out a way. So if there's a biological experiment aboard, if there's some other electronically sensitive thing, this unit can keep it from spinning while the rocket is spinning all around.
Right.
That's awesome.
Yeah. Let's say if you want to take some solar measurements in this rocket, but the rocket is spinning and there's only one window. So you need a source which would keep it stable so that it can take the rays continuously. So if you keep any experiment out here on this platform, it would be stable with respect to the sun at all the times.
Oh, my. Well, let's get to the proof of the pudding here. The rocket went up, came back down, landed in the ocean. NASA retrieved it. You've got it back, obviously. This is what was up in not orbit, but I guess in low Earth space. Dr. Kang, did it work?
Absolutely. Students did a wonderful job putting it together. We tested it before we put it on the rocket. And we put it on the rocket, went up, functioned, came back down. We looked at the data that came back, and it was working fine for first about a minute or so, and then there was a little discrepancy in the data that suggests that something might have gone wrong. So we're now looking at the data in more detail and trying to investigate what happened there.
But your preliminary report or finding is that you're on the right track, that this can work.
Correct. This was our first prototype. As the data shows the rocket's spinning up, so we correctly measured.
Okay, so if I'm NASA, I'm on the phone to you guys going, wow, that's cool. Come work for me. Or you give me your idea. What was NASA's response to this?
NASA, the review board was excited to hear about this experiment. There are all different types of experiments that go on it, and they thought this one was particularly interesting.
All right, well, we'll talk more about this in a moment. More on Drexel Innovation in Space when NBC 10 at Issue comes right back. Stay tuned.